Howdy, Huskies. Welcome to the first video here of the second semester. Now, I'm doing this still in 2020, but you guys are going to be watching it in 2021. So it's almost like this is the past telling you about the future. Oh, God, that's crazy. Alrighty. So, ladies and gentlemen, let's get this party started. So the first thing that we're going to do is have you try these review problems. So jump on them, and then I'm going to hit unpause, and the answers are magically going to be there. Ooh. Alrighty, well, welcome back. Let's see how well you did. So the first one, remember the period of tangent and cotangent is pi. For everything else, it's pretty much 2 pi, unless we have a shift, but we're not doing that in this review. Cotangent of 2x, remember at 0, that's where we're going to have an asymptote, so hence why it's undefined. And then lastly, this is going to be 1, because remember it comes from our Pythagorean identity of sine squared theta plus cosine squared theta equals 1. So whatever that trig is, or theta is, it's always going to give us 1. Cool. Alrighty, so ladies and gentlemen, I am going to do some more math magic, and I'm going to go ahead and hit pause, and when I unpause, all these lovely rules will be right here. Alrighty, so hit pause and write down all these rules if you haven't done so, and then welcome back. So for the cosine rules, the things to remember is one, there's going to be a lot of rules, so let's try to just make sure we are all gravy, is that both of these are just do the cosines and then the sines. So it's basically the cosine of your first term and then your second term and then the sine of your first term and your second term in both of these. Now, what you're going to notice is that it's going to be the opposite sign of whatever you have inside of your parentheses. That's a plus, so this is a minus. This is a minus, so that's a plus. Cool? So now we're going to do the same thing with sines, so magically they're going to appear. So welcome back. Now we have our sines all set. So notice here that the pluses go with each other and the minuses go with each other. And that basically it's sine of the first, cosine second, cosine of the first, sine of the second. Or the sines are on the outside, cosines are on the inside. Cool? All right, last but not least is the funky tangent one. So ready, set, poof. So ladies and gentlemen, as you can see, the tangents are a little bit saucy. Okay, so I guess find a good spot to have these written down. To try to remember them is kind of crazy. So just have them in a spot that you can reference them and go. The nice thing about the tangent, though, is that these values are always going to be basically the same ones, where on your cosines and your sines, you're going to have to find 4 different values. On the tangents, your tan x's and your tan y's are going to be the same number, so you're remembering a little bit of a saucier rule, but at least the values are a little bit easier. So, ladies and gents, before we go to apply these rules, let's think about this really quickly. This is why we care. When we did our trig last semester, you basically had to be somewhere within this wheelhouse between 0, 30, 45, 60, or 90. Or 0, pi over 6, pi over 4, pi over 3, pi over 2. If it wasn't one of those, we needed to find a calculator. Well, in the days before calculators, what was a tool that they gave us to find something like 15 degrees or 115 degrees, something a little bit more, 75 degrees, something like that. And the way they did is they derived these rules. Now, if you are really, really bored, watch the derivation videos on this. They're a blast and all sorts of sauciness, so just take it at our word for it. But basically, this just gives us a way to open up using this. So I like to call this our wheelhouse because that's what we're still going to be using. This is our unit circle. We're not going to be changing that, but it just gives us a little bit more options moving forward. All right, so let's give us an example. So I'm going to start with just kind of zooming here and say, okay, cosine of 15. So if I go, okay, I have 0, 30, 45, 60, 90. I start with those. How would I get to 45? Well, we've kind of gotten that started for you already. So we already have you kind of set up. We could say, how do you make 45 using this? Well, 1 is positive, so it's going to be a bigger number minus a smaller number. So that's how we're saying 60 minus 45. Okay, so the first thing you're going to do is you're going to say, okay, which one of the rules am I going to use? Obviously going to use the cosine. Then the next thing you need to know is what's the sign in here. So this is basically going to be our rule, and this is going to be the sign that we really need to be taking a look at before we move forward. So obviously this is going to be a cosine. So let's remember our rule. So cosine of x sine, cosine of y plus sine of x sine of y. So that's the rule that we're going to go ahead and use. And so we're going to call this 60 our x, because the first one's always x and the second one is always y. So first is x, second is y. So let's go ahead and plug it in. Just make that different a little bit. So all my y's are going to be the 45s, and all my x's here are going to be the 60. So let's go ahead and roll in. So we're going to have cosine of 60, cosine 45 plus sine 60, and then sine 45. So at this point, we're going to go ahead and use your unit circle, do whatever you need to do to get your values. So we have cosine of 60, that is going to be 1/2. And then cosine of 45 is root 2 over 2. Sine of 60 is going to be root 3 over 2. And then the next one's root 2 over 2. Okay, so what I'm going to do now is just basically do your Algebra 1 radical chapter in about 2.7 seconds. So hold on tight. Okay, this is a radical. This is a constant. When you're multiplying a constant and a radical, you're just going to put them together. So 1 root 2 over 4, because you're going to multiply your multiply across. Now in the second one, these are both radicals. So we have a rad and a rad, and specifically they're both square roots. So we're going to go ahead and multiply those insides together to give us 6 over 4. Alrighty, so now that we have a common denominator, this is going to become root 2 plus root 6 over 4. Now, the big thing is these radicals, the only way you can put these radicals together, and we will see that in a future example on our notes, is if they're both root 2s or they're both root 3s. But since one's a 2, one's a 6, you can't combine. Okay? The next thing you're going to want to do is reduce, and we're going to see this later. But you can only reduce like roots. So when I think about like roots, I mean that let me take that back. You can only reduce things that are alike. So I've highlighted here in red all what I would consider to be the outside numbers or coefficients. Nothing you can reduce. Here, these are all my radicals. Now, since the 4 has no radical, there's no reducing that you can do there. So there's a lot of radical rules that you got to remember, but this is just basically going to say that this is root 2 plus root 6 over 4 for our answer. We're going to see lots of variations of this, just because we see a lot of root 2s, a lot of root 3s, and 1/2 because that's our wheelhouse for our unit circle. All right, so again, let's look at, I'm going to a negative 15. I don't know that on my unit circle, but how can I use my wheelhouse over here to make that? Well, one, I know it's negative. So to get that, I'm going to have to do a smaller number, and I'm going to subtract a larger number on my wheelhouse to get that. So in this case, that's going to be 45 minus 60. So let's take a look. This is a sine rule, so this is going to be the rule we're going to use. And then this is a negative, so that's the sine version that we're going to go ahead and do. So it's going to be the sine of x cosine of y, and then minus the cosine of x sine of y. I don't know if this is helpful, but I kind of like to remember that the cosines are on the inside for your sine rule and that your sines match. So this is minus, that's minus, and you're good to go. All right, so the sine of 45, the cosine of 60, minus the cosine of 45, the sine, I almost wrote sine, of 60. All right, so let's use our unit circle, find what those values are. So root 2 over 2 for the sine of 45. And then this is going to be 1/2. And then we have a minus in between. Cosine of 45 is root 2 over 2. And then the sine of 60 is root 3 over 2. So let's do our radical rules again. So on the top here, this is going to be a root 2 over 4. And in the second part, we're going to have, move my desk over here a little bit. This is going to be minus root 6 over 4. Put those together. This is going to be root 2 minus root 6 over 4. Dunsky. Cool. Easy peasy lemon squeezy. Now, if I were teaching this in class, I would say, okay, look at number 3. Obviously, this is going to be rather than radicals, okay? It's the same sort of idea. So hit the pause button, give it a try. See where you're at, okay? Again, our real house for this is going to be pi over 6, pi over 4, pi over 3, pi over 2. So welcome back. Hopefully you gave this a try. If not, that's cool too. We're learning. So how are we going to do this? Well, you have a 12. Well, the only way to make a 12 is to find a common denominator, which means these are going to be pairing up. So if I did root 6 plus root 2, okay, I would get one number. But what I'm going to be looking here is root 3 plus root 4. Do a common denominator. I'm going to do this super quick. 4 over 4, 4 over 4 here, 3 over 3 here. So that'd be 4 pi plus 3 pi over 12. So those are the two we're going to put together. So this becomes cosine of pi over 4 plus pi over 3. Cool. Now we're going to go ahead and apply our rule. Obviously, we're going to use the cosine rule. We're going to have the plus. So we'll do cosine of pi over 4. And then the cosine of pi over 3 minus. And then we're going to do the sine of pi over 4. And then the sine of pi over 3. Cool. So notice we have for our cosine rule, cosine, cosine, sine, sine, good to go. Different sign change there. Perfect. So now we're just off to the race. So see, if you want to make sure that you haven't done this part yet or give it a try, you can hit stop and try it. If not, we'll carry on. So this is going to be root 2 over 2 again. And then the cosine of 60 degrees essentially, which is pi over 3, is going to be 1/2. And then we'll go ahead and go minus root 2 over 2, and then root 3 over 2. So in this case, we're good to go. Just making sure. Root 2 over 2, root 2 over 4. And then minus root 6 over 4. And this is going to give me root 2 minus root 6 over 4. Boom shakalaka. Alrighty. So as we move on here to tangent, just a couple of things that you want to make sure you're all good with. One, make sure your signs are right. Okay. The second thing is if I go back and I look at this, I want you to do the whole numerator. So do this whole numerator part, and then you're going to do the whole denominator part, and then simplify your fraction. Okay. So we're going to get some algebra work on this one. I'm going to erase every. Sorry about that, sports fans. We were going to jump around here. Things got a little, my pen decided not to work. So this is tan x minus tan y over 1. That's not a 1. 1 minus tan x tan y. All right, so again, the nice part, make sure I write my rule right. The nice part is that these tan x's are going to be the exact same value, and then these tan y's are going to be the exact same value. So that's going to actually make our life a little bit easier. But all we're going to do is I'm going to worry about my top first, and then I'm going to come by and worry about my bottom. All right. So let's go with this tan of pi over 6 minus tan of pi over 4. So, ladies and gentlemen, that's going to go ahead and give us root 3 over 3 minus 1. So because I need this to be one fraction, and this is going to be a crucial part of our tangent ones, is I need this numerator to be one fraction. I'm going to put that 1 over 1 and then multiply by a common denominator. So this is going to become root 3 over 3 minus 3 over 3, which is going to go ahead and give us root 3 minus 3 over 3. So since that's one fraction, which is what we want that to be, we're good with our top. Now let's go ahead and mosey on with our bottom. Like I said, make sure you do your signs right, or else you're going to go to the very, very end and realize that you made a mistake at the very beginning. So let's go ahead and take a look at this. So this is supposed to be a plus, and that's what I did wrong. So here's what we need to do, and this is our rule. So this is going to become 1 plus root 3 over 3 times 1. So this will be 1 plus root 3 over 3. Now we're going to have to do a little common denominator action, so just like we did before. And so this is going to become 3 plus root 3 over 3. Cool? So I'm just going to go ahead and say it's easier if you write them with your real number first. So I'm going to make this a negative 3 plus root 3 over 3 to match this 3 plus root 3 over 3, just so my radicals are second, my constants are first. I didn't change anything, so we're good to go. So now we're going to make this divide, because that's really what it is. And so remember, when you divide, you're just going to go and take that second fraction, you're going to flip it, and you're going to change this from divide to multiply. So this is going to be negative 3 plus root 3 over 3. Flip the second fraction. And boom shakalaka, here we go. So the 3's will cancel out. Everything's going to be nice and easy. So I get negative root 3 plus 3. 3 plus root 3. Alrighty, now we say that this is nice and simplified, everything is good to go. The problem is we're not allowed to have any radicals in our denominator. So this is what we call a complex conjugate. And it's a saucy one at that. But the idea is you take your denominator and you multiply the top and the bottom by that denominator, but it's got to be the flipped sign of it because it's going to make it a perfect square. And in our perfect squares, that second term will cancel out, or the middle terms will cancel out, specifically that radical. So let's go ahead and do our first outside, inside, last. So boom, 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 boom. So this is going to be a negative 3 times 3. So that's going to be a negative 9. Then negative 3 times this is going to become a minus 3 root 3. Then on our insides here, I'm going to go ahead and get a negative 3 root 3. I had to hit pause because, of course, another sign change. I'm not going to record it again. I'm just going to fix my signs and move on. So we did our top. We're good to go. These are exactly our like terms right here in the middle. And these are our like terms on the outside. After you've recorded this video a couple of times, you're just like, let's just get through it. So negative 12 plus 6 root 3. Is what we're going to get on the top. Now we're going to do the same thing on the bottom, hopefully with no sign change errors. That'd be great. So first outside, inside, last. So we're going to get 9 and then a minus root 3, a plus 3 root 3, and then a minus root 9. And then you're going to go ahead and see that these are opposites, so they'll cancel out. And so what we're going to just get is 6. Because we'll get 9, this will become a 3, so we have our 6. So now, as I mentioned before, all these are outside the radicals, and you can divide into all of those. So I can divide each one of those by 6. So this is going to become negative 2 plus 1 root 3 over 1, which is just simply negative 2 plus root 3. So that's what it simplifies to. Woo, Lord! Lordy. So just make sure your signs are good. Alrighty, in these next examples, we're going to go ahead and just say, remember that you can use our identities to go backwards and make your life a little bit saucier. So if we look at this, we're like, okay, notice we have 40 and 40, 20 and 20, alrighty, and then we have a minus in between, and we're like, okay, this is looking like we have a cosine rule. So if we look at our cosine rule, and I use a minus, I would say, okay, this is really cosine of x plus y. So we went cosine, 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 sine, sine. So in that regard, we're like, okay, let's simplify this to go, and rather than from expanding it using the rules like in our other examples, to condensing it. So if I condense this, this is going to become cosine of 40 plus 20, which is going to become the cosine of 60, which we know what the cosine of 60 is. That's 1/2. So you can use these to help you as well, make things less complicated. In this next one, you're like, okay, clearly a tangent rule here. We have a plus in between. Notice it goes 20, 20, 45, 45. Cool. We'll go, okay, let's make this tan. Again, because it's a plus on the top. As I said previously, those signs match for the tangent rule. So this is going to be 20 plus 40, sorry, 20 plus 25, which is going to give us tangent of 45. And we know what the tangent of 45 is. For a unit circle, that's 1. Boom. That makes it go a little bit faster. Alrighty. So number 7 is another example where you guys are going to take your algebra and run with it. So my friends, we have our x and our y all set. We have our plus, so we know it's going to go tangent of 2 pi over 3 plus tangent of pi over 4. Let's just, again, just worry about the top. We know we have a bottom, but let's just worry about the top first. So on the top, that's going to be a negative root 3 over 1, or negative root 3 plus 1. Now the nice part here is that this will count as our 1 fraction because all this is really over 1. So this counts as our 1 fraction. We should probably have done this example first. It's a lot faster. So 1 minus tan of 2 pi over 3 tangent of 4 pi over 2. So this is going to be 1 minus root 3 times 1. Sorry, I got to get my negative in there because, again, as I mentioned before, those negatives will eat you alive if you forget them. So a negative and negative is going to make this a positive. So this is going to be 1 plus root 3. So again, that's 1 fraction. So really what we have here is root 3 plus 1 over, excuse me, make sure I get this right because I forgot my sign again. So this is 1 minus root 3 and then 1 plus root 3. Again, your signs are going to, if you don't pay attention, like I've shown you on this example and the previous one, they'll get you. All right. So this just means divide. So we're going to have, in this case, we don't need to do the skip and flip. So we'll just rationalize. So 1 minus root 3, 1 minus root 3 because of our complex conjugate here. So when we do our multiplying, our first outside, inside, last, on the top, we're going to get 1 minus 2 root 3 plus 3 over 1 minus 3. So this is going to go ahead and give us, if I combine these like terms there, 4 minus 2 root 3 over negative 2. Everything is divisible by, in this case, negative 2, because let's just make it over 1, make our life easier. So that's going to be negative 2 plus root 3. And we're done. Cool. Alrighty, ladies and gentlemen, boys and girls, it is now time to do some more proofs or verifying identities, however you want to do it. Now, as you can mention, we could talk about factoring. We can go working on either side of this, but let's just give it a shot. So notice I have a cosine of an x, so that's obviously going to be our x term, and then that's going to be our y term, which is our pi over 2. So this is our cosine rule, so we'll do cosine x, and then cosine pi over 2 plus, and then we'll do sine of x, and then sine of pi over 2. So my goal is to make this equal sine of x. So if I notice that this is my sine of x right now, I'm hoping that everything else goes away, including, my friends, this cosine x right there. So I'm like, okay, I need to be focusing on making sure that goes away. Well, let's look at this cosine of pi over 2. We know that that is 0. So anything times 0, even if it's a cosine, is going to be 0. And then we'll look over here and say, all right, I need this to go away because I just want it to be sine. Well, then the sine of pi over 2 is going to be just 1. So this is going to be sine of x times 1. So that's just going to give us sine of x. And that's what it's supposed to be. So in this case, 0 plus sine of x is going to be sine of x. And that's what it's supposed to equal. So thus verified. Checkarooski. All right, our next example here is clearly a tangent rule that we're going to use. And we're going to use the tangent. This is a minus, and we want to make it so it's negative tan. So the first thing is, let's go ahead and expand this out. So tangent of pi minus the tangent of x is equal to 1 minus tangent pi tangent x. All right, so the first thing we're going to go ahead and remember is that this is tan x, and it's negative. And this is a tan x that's negative. So we're hoping that everything else kind of drops out. So let's go ahead and use our unit circle to remember that tan of pi is 0. So 0 minus tan of x, off to a good start there, loving it. And then remember, if those are all going to be the same, so I'm going to say, okay, that's a 0. So it's 1 minus 0 times tangent of x. So 0 tangent of x. So 0 times anything, as we just mentioned, is going to give us 0. So on the top here, we'll get 0 minus tan x over 1. Well, anything over 1 is going to be 0 minus tangent x. Well, 0 minus tan x is just going to give us, whoop, negative tangent x. And that's what we want to have happen. Yay! All righty. So this next one looks a little bit funky, but that's just because of our Greek symbols. So this is alpha and this is beta. So notice we have alphas and betas here all over the place. Alrighty. So what we're going to do is we're going to say, let's look at this. So here I have a plus and this is a minus. So let's write our sine rule here. So it's going to be sine of alpha and then cosine beta plus cosine alpha sine of beta. Alrighty, making sure that looks good. Looks alright so far. Alright, then we'll do the next part here. And that's for this one now. It's basically the same thing. So plus, and then sine of alpha, cosine beta, and then minus, we're going to have cosine alpha, sine beta. Alrighty, so we have everything written out here. And what do we notice? We're like, well, hey, these two pieces right here are exact opposites. So they're going to cancel each other out. And then we say, well, wait a minute, these are exactly the same. Let me do that in a different color here. Exactly the same right here. So what we would do is if I had x plus x, well, that would give us a 2x, right? Well, we have, rather than x, we'll just say it's these pieces right here. So it's going to be 2 sine alpha cosine beta. Boom. And that's what we want to have happen right there. Love it. Excellent. Spectacular. Alrighty. Last but not least, we have this one, and this one gets a little saucy because we're going from sines to tangents. So the first thing that I'm going to go ahead and say, remember, is eventually I feel like I'm going to have to do tangent is going to be sine over cosine. Cool? So let's keep that in the back of our minds, and maybe we'll use that to help us as a direction towards the end. Because I am going from sine to tangent, where all the other ones, it was from sine to sine, cosine to cosine, so I felt like I was staying in the same wheelhouse. Now, let's do our rule here on the top. So sine alpha again, cosine beta plus cosine alpha, and then sine beta. And then all that over cosine alpha, cosine beta. Alrighty. So noticing our bottom isn't any rule that I'm familiar with. So I'm like, okay, a little bit stuck here. So let's go back to right here. I don't have enough to use this piece yet, but I do mention that, or I do notice that this is two terms. Okay, this whole thing right here is one term. Okay, let's think about this as taking this plus part and making it two separate fractions. Much like if we had 1 plus x over 2, I can make this 1/2 plus x over 2. We can do it that way. So let's use that sort of idea here. So I'm going to take this whole first piece and go sine alpha cosine beta over cosine alpha cosine beta. And then we'll do the same thing with the second part here. So cosine alpha and then sine beta over cosine alpha cosine beta. Put a plus sign in between. All right, always a huge fan of seeing stuff cancel out like you've seen in the other videos before. Like if I see a cosine beta and cosine beta and a cosine alpha and a cosine alpha, bye Felicia. Sine alpha over cosine alpha plus sine beta over cosine beta. Oh, it's like a holiday present right here. We just said, hey, sine over cosine. So we said this is theta. So let's use another Greek letter like our alphas. As long as those match, we're good to go. So this is going to be tangent alpha. And then this will be on the next one, beta beta. So this is going to be plus tangent beta. And then that's what we're trying to do. Bazinga. Alrighty, ladies and gentlemen, hopefully this helped for your first part of our rules. So again, have all these rules somewhere written down to help you out. Make sure you're taking a look for those signs, making sure everything looks good, and we will catch you on the flip side. Not now.